Good afternoon. Hello.
Good afternoon, sir.
Yeah, am I listening? No, you can listen me, no? Okay.
Yes, sir.
Yes, yes, yes.
Whether you will start or we shall wait for 5 minutes.
Yes, sir. We will
Sir, we'll
start
be
soon,
starting
sir.
at 4 o'clock.
Hello. Good evening, everyone. A warm welcome to our respected principal, sir, respected faculty members, my dear seniors, and my friends too. Today, on behalf of Department of Mechanical Engineering, Techno Engineering College, Banipur, we are going to commence today's competition, hosted by Mechanical Engineering second year student, me, Sritama Pal, and my co-host, Ritik De. We feel privileged to host this program. And today we are going to host the competition, the Mechanical Way Final, in which qualifiers are already selected from the pre-final round, which was held on 10th and 11th June 2021. Congratulations all the teams. And before starting the program, we want to give thanks and regards to all our faculty members for giving us the golden opportunities where we can show our talents and knowledge regarding our subjects. Thank you, sir. And with their fruitful guidance, we all are up here to appear for finals. Okay, thank you. Now over to my co-host Ritik Dey.
Good evening to respected sir and teachers. So today we will be starting our final rounds about the presentation competition. So before that we start, I want to call upon our respected principal sir to give some warm words about the final. Sir, please take over the mic.
Well, good afternoon to everyone,
Good afternoon, sir.
right? Now you see you are submitting project, right? These projects are very much, there is a two words. One is use, another is the ET. Your project must be utility to gain the or the score much more, right? Now in the case of the mechanical engineer, as I have heard, that the mechanical engineering means there is a two words that you have heard the name of the core sector, right? And the core discipline. Just core sector means you see the power sectors, minings and mineral, cement industries, heavy engineering and allied. These are the sectors which are increasing our GDP, the country's economy. And from here, they are the feeding to the other discipline, other industries, where they can develop their product or enhance their product by increasing their productivity. Now come to the mechanical engineer. It is a core sector. So that means this is the sector from which you can find out a lot of branches. Now, the mechanical engineer, if you see for the steel industries, you see that you have heard the name of the Durgapur, you have heard the name of the Bokaro, you have heard the name of the Rourkela, you have now heard the name of the Vilai or the Durg, you now heard the name of the Salem. Every in steel industries is producing the different things. Durgapur is for the bridge and other things. Bokaro is producing the rods and seats, etc. Rourkela is producing the engine bogie and other. Vilai is producing the railway line and others. And the Salem is producing the utensils, steel utensils. These are the one of the factors steel industries, right? Similarly, in the case of the mechanical engineering, we can go for anywhere. You see, earlier you are making the drawing, etc., through your slides or the T square and set square. Now you are going for the AutoCAD, right? The mechanic now for that AutoCAD, that is the mechanical engineering means you are a core sector from where you can go the aviation industries, you can go for the armies. The army has a three unit. One is the artillery, another is the navy, another is the air force. You can, the three avenues is open for the mechanical. No other discipline will get it. Now the in the case of the mechanical, other sectors is also automobile industry, you can go, aviation industries, you can go for any steel industry, you can go any piping industries, you can go for the automobiles or the heavy earth movers or machineries, even you can go for the well digs also. So if you say the mechanical engineer, but the thing is that you must have to have a knowledge of the one language. That means I am saying for the language means the computer language. Either you know the C++ or C++, but whenever you will publishing papers, the peoples are the international or national journal, they are asking for the software. They are asking for the how you can get out the result. You see, the whenever you are doing some project work, you are getting some yield, the result. The how this result is useful and how you can do it for the society or the community as a whole, you must have to think besides your economical impact on this project, right? These are the all things which you can get from the mechanical. For the mechanical engineering, you can for the IT sector. Now the IT sector is recruiting the mechanical engineer. Even in case of the, I shall say, the unmanned vehicles or the drone, you can say, the 80% is operated by the mechanical engineering. 10% is for the electronic circuit and control, and the 10% is the software. This is everywhere, even in the army, artillery, you can, then the 90% is the mechanical engineer. So these are the things you see in the mechanical engineering. There is a three steps. You see from the ITI levels, you can see the more discipline in that. That is the grinder, the milling, the machinist, the turner, every carpenter, everything is the ITI. And from the ITI, you can come to the diploma, where they are have a little bit knowledge about the supervision. They are also knowing, understanding the digital systems of the application of the mechanical. But for a mechanical engineer, you are the clubbing of all the things. You must have to have a knowledge about the core sector. You must have to knowledge about the design sectors. You have to knowledge about the be a little bit about your applications part of the IT. Higher study also. If you go for the US and other Manchester University, everywhere you can find. If you are a mechanical engineer, oh, most welcome. But if you are a computer or IT, or they have a very limitations their application. Hello. Hello.
Yes, sir.
You are audible, sir.
Can you understand? Hello.
Yes,
Can you
yes,
I
audible?
think you have having some network issues,
clear.
sir. Hello?
Hello.
Sir, yeah, you are having some network issues, sir.
Now it is clear, I think. Are you able to listen now?
Yes, sir. Yes, sir. Yes, sir.
So have you, whatever I have told, have you listened? Or I shall do repeat once again.
Sir, it will be helpful if you repeat, sir.
Hello. Right? Hello.
Yes, sir. Yes, sir.
What I am to want to say, the mechanical has a worse exposures with the compared to the other discipline as well, right? The mechanical has an exposure to the industrials of the heavy engineering compositions, the heavy automobiles, or besides the minerals also, and simultaneously aviation industry, automobile industry, and everywhere you can have a good exposure. Now, in the case of the mechanical engineering, if you have a knowledge of the IT, say IT, and if you have a knowledge of the one language at least, then it will be the better for your more exposure to the industry, and industry will be acceptable for the mechanical engineer. It is not only the core sector, but it is the prime mover of the industries as well. That's why I'm saying you the mechanical engineer don't lose your heart, and whatever you are doing in the project, it will be very, very useful, and utility is much more in the impact on the society and the community as a whole. Okay? Hello, Hitik? Hello?
Yes, sir. Yes, sir.
Now over to you. You can continue your project. Okay? Thank you.
Thank you, sir. Thank you, sir, for your warm words. Now I want to call Pritoma Pal to call up our sir mechanical TCB head to give some the warm words.
Yes,
Pritoma, please take over.
Yes, Ritik. Thank you so much, sir, for being such an impactful leader and motivating us to strive for success daily. And we can't thank you enough for all you have done as college principal. So after the motivational and inspiring speech given by our respected principal, sir, I would like to call upon our teacher in charge, respected Bidhan, sir, to render his speech. Sir, please take over.
Can you hear me?
Yes, sir.
Yes, sir.
Okay. Thank you. Present, respected principal sir, distinguished judges, Mr. Subhangan Basu sir, and all the participant teams. I would like to first thank you, principal sir, for his inspiring words towards the uh, program, the mechanical way. The mechanical way, he generally elaborates the different parts of mechanical way of this program, and I am very much thankful for his valuable time and valuable speech regarding this program. And the main motive of this program is to reach the people who have the misconception about mechanical engineering department and the mechanical engineers, and what we do, and what are the different applications of mechanical engineering in our daily lives. And in order to promote this, we have generally created a Facebook page, and I would like to request Mr. Shubhankar sir to share his screen so that we can show the Facebook page which we have created to promote our promotional strategy, which will be published in our Facebook page. Shubhankar sir, can you hear me? Hello.
Yes, sir. You are audible.
Okay. Okay. Somehow, sir is
Just a
missing.
minute.
Yes. Yes. Okay. Let him share the screen. Then I will explain. The page is generally created for the students and for the people who generally belongs to mechanical engineering community, whatever it may be, that may be student, that may be teacher, and that may be any other person which generally who are generally contributing towards the society as a mechanical engineer. This is our initiative to promote the mechanical engineering department and the contribution of mechanical engineers toward our society. And, I would like to request all the students to share this page with your friends, and first of all, you like the page, okay, and share your thoughts, information regarding anything that is related to mechanical engineering department. You can share with this page. That page is generally dedicated to you. You can share all of your or thoughts, all of your ideas, all of your project related to mechanical engineering department, so that we can promote as a mechanical engineering, as a mechanical engineers. That is what is our contribution towards the society, and what mechanical engineers can do for the society, and what are the generally scopes, different scopes in future in the mechanical engineering department. So I think the page is here. Just wait a minute, and after this, I will conclude my speech, because there are so many teams. They have to produce their presentation, and we have to listen them. Okay, we are. Are we ready, Shubhankar sir? Okay, just.
Yes, sir.
So all this thing that is we are organizing for the department, not only for the department, we are organizing for the mechanical engineers. Okay, and as a mechanical engineers, I think it is our duty to reach out those people who have the so-called misconception about the mechanical engineering department, that mechanical engineers can only work in the code field, they have no value in the IT sector or software sector. That is generally misinformation, and which has no base. So we have to reach them throughout our social media platform, whatever it may be. Whenever you get some chances to speak about something, then you can speak about the mechanical as a mechanical engineers, and I think it will give some value towards the mechanical engineering community. And we are generally organizing this program this semester in this year also, and we have also decided to organize this program with version 1, 2, 3, 4 as like this for the next semester, and after the next semester, then also we will continue to promote our campaign regarding the mechanical way, which will add some value to mechanical engineering community. And here is the page. You can see that that is the page is created from our department of mechanical engineering, and the name of the page is the mechanical way, and you can read, you can easily understand the name, that is the mechanical way. What are the different way that is related to the mechanical engineering, and as the principal sir said, 80% things that is generally related to mechanical engineering department. Okay, only rest of 20% things that is generally done by the other departments, and we have to promote our the true value. That is why we have to promote our works that is generally related to mechanical engineering department, and that's why the page is created, and that this page is dedicated for you, and you can share this page with your friends. You first of all you have to like, you can all are requested to like the page, and if you wish to share it, you can share share the page with your friends, family, and any other people who is related to the mechanical engineering. And I think this will generally create a positive value for mechanical engineers, and this will give some weightage towards the mechanical engineers as a society. As a society, we can what we can do for our society, and what is generally coming up in future to being a mechanical engineers, to be a successful mechanical engineers. And that's all I would again request all of students to like this page and share your thoughts, videos, project ideas, and any talks that is related to mechanical engineering. You can share this with this page. You can share your thoughts, videos, music, anything that is must be related to mechanical engineering. You can share on this page. Okay, and without extending my words, I would like to again thank you, Principal Sir and Shubhangan sir, for being here with us. And lastly, I would like to wish best of luck to all the participating team. Okay, thank you. Over to you, the moderators.
Thank you, sir. Thank you,
Thank
sir,
you, sir.
for your words and for thank you, sir, for your words and for giving us such opportunities to express ourselves in the through social medias and the Facebook page. So this will be helpful for other students also to learn about the mechanical engineering and all the parts related to it. So now, without wasting any time, I will to call upon our first team, the team of Debru Mukherjee. Please take on the platform. The platform is yours.
Okay, sorry to say that, but we are facing some network problem. So can we delay this for 15 to 20 minutes? The program must be carry on. So please, sir, I
Sir,
am requesting that.
No, no, it will be very late if you delay for 15 or 20 minutes. Okay,
Sir,
you have to.
then 5.
No, no, no. We can give you only 2 minutes. You have to fix it. Otherwise, it will be considered as it is.
Okay, sir, I am trying.
Let's try. You can fix it. Next team is requested to be prepared. If there is any problem related to the serious problem, then you have to participate. Okay, and the first team slot wise you have to participate. If the first team does not appear, then the team will be disqualified.
Debru Mukherjee, can you start?
Hello, am I audible?
Yes, you are.
Okay. Good afternoon to our respected teachers and principal sir, and good afternoon also to my friends and my fellow teammates who are present here. Techno India Banipur presents the Mechanical Way, an interdepartmental competition. So today is the final day of our competition. Our team members are Devrup Mukherjee, Soumalla Chakraborty, Manibandha Bishwas, Obhijit Jash, and Obhijit Hajra. So here is the content of our today's competition topic. So as we all know that COVID-19 is breaking out during those days, and they are spreading rumorously, and it is considered as pandemic worldwide. So now, what are the effect of society without mechanical engineering? What are those future prospects of mechanical engineering after this COVID-19 outbreak or this crisis? And what are the career opportunity as a mechanical engineer? So I would like to request my fellow teammate Ovijit Jash to represent the topic number one. Over to you, Ovijit.
Thank you, Somallo. Good afternoon to our respected principal, sir, and teachers, and present our respected judges and my loving fellow classmates. Before starting our presentation, I would like to thanks to our respected teachers for organizing such astonishing event during this catastrophic situation. In this presentation, I'll be covering effect on society without mechanical engineering. Now let me tell you why mechanical engineering is important to our society. Well, mechanical engineering is a branch of engineering which itself acts like a polymath. Polymath means the subject has a diversity or versatility. It plays a pivotal role to accelerate our society. Without mechanical engineering, we still may stuck into the ancient age. If there is no contribution of mechanical engineering, then there will be no manufacturing. No manufacturing means no machines and no mobility. It makes our life a bit easier, and day by day it advancing for making mankind's life more easier, like manufacturing cars, building bridges, or an aeroplane. Apart from that, existing our life, we need food. For that, we have to cultivate. Cultivation would be a bit hostile without the contribution of this branch. For farming, we need plow, which requires forging. For producing crop, we need to irrigate the farmland, for which we need pump. Without pump, production might be less, and for cutting it, nowadays people are using rotor machine. Above this information shows us that how much mechanical engineering has been intruded in our life. Well, mechanical engineering is all about the principle of physics, mathematics, and material science to analyze, design, and manufacture mechanical system. When it comes to build modern marvel like Burj Khalifa or Rolling Bridge of London, well, Rolling Bridge of London is a unique form of engineering could easily fold and shape like a circle with the help of a hydraulic system. Or Gateshead Millennium Bridge at Tyneside is also an amazing movable bridge, which curved up to 40 degrees, fixed endpoints rather than lifting or bending with help of motor. Like this unique bridge also listed in Guinness World Record. Apart from that, in our daily basis life, we also use many devices such as refrigerator, oven, etc. These examples reveals that how mechanical engineering made our life easier. Next slide, please. Well, without mechanical engineering, there may not be any health sector. During this pandemic, we all have seen that devices like oxygen therapy device or ventilator or CPAP, continuous positive airway pressure. Without this, saving life would be a bit difficult. For instance, there are many more machines like 3D printer, Thrombolux for blood platelet analyzing, or super pump for pulse duplicator that test heart, cardiovascular, etc. When it comes about development, mechanical engineering is always young as morning and old as sea. Day by day, it enhancing our transportation system. To give an instance, British inventor George Stephenson, who created the first inner city railway system, this is of course reset the transportation system. With help of mechanical engineering, automobile system is also improved into hybrid electric vehicle and electric vehicle, which helps our society to prevent from carbon emissions. At the meantime, mechanical engineers also focuses on durability. Scientists from MIT, ETH Zurich, and Caltech find a new carbon-based nano-architected material which is tougher alternative to Kevlar and steel. Next slide, please. Well, in past decades, thinking about space was just like a space cadet. with advancement of technology, it has possible to reach to the space. Thank you. I would like to over it to my fellow classmate Somallo Chakraborty.
Thank you, Abhijit Josh. So the next topic is about what are the future prospect of mechanical engineering after the COVID-19 crisis. As we all know, during the COVID-19 outbreak, many people are falling infected, and it is a contagious virus. So, as a mechanical engineer, basically deals with machines, equipments in those factories, and they need to visit those industries. There are many firms like IT firm, electronics and telecommunication firm who have those possibilities, who have those criteria in their hand that they can work from home. They have those capabilities that they can work from their home. But mechanical engineer have never been work from home, and it poses a very difficult problem to the industries. But due to this COVID-19 outbreak, the entire platform has been shifted. Everyone has to face the new normal. They have to accept it. But yeah, there is accept of mechanical engineering after this COVID-19 crisis. Emerging to some new domain in mechanical engineering, design, prototyping, 3D printing are some of those softwares. Softwares like computer-aided design, computer-aided mechanism, that is CAM, CATIA, and other software which does design and prototype any machines. Rather than that, there is other software like MATLAB, CATLAB, which are used by CNCs and EDM machines, modern CNCs and EDM machines for cutting off their job. So this prototyping, this designing can be done at home. They can be worked at home. They can be done anywhere in the world, from any part in the world. But those who are for production unit, who are making for production unit, who are there for supervising, they need to visit those industries and factories. Without them, nothing would be possible. This COVID-19 crisis presents mechanical and plant engineering companies facing unprecedented challenges. There are some companies who are having the temporary halt, and production has been postponed due to this COVID-19 crisis. Other than that, the mechanical engineer also in this current scenario joined hand with the medical engineer to fight against this coronavirus pandemic. The most hot cake item in this current situation is oxygen concentrator, mechanical ventilator, and setting up of hospital beds. These are some domain which fall under mechanical engineering. Mechanical engineering joining hand with the medical have also started building those machineries. So they may defeat the coronavirus. This joining hand with the medical engineer pose a foundation of a new domain in mechanical engineering field. Now, talking about the order scenario, obviously due to this COVID-19 crisis, many orders are getting delayed because there are many different companies who are facing temporary halt. There are other companies also who are shutting down their companies due to the loss, due to their production has been stopped, and they are facing the capital losses. So nowadays we know that there are many different companies who have to run for running their companies with 50% workers. This is done because of the workers and because of the fact that the worker will not be get contaminated with this COVID-19 viruses. So running those industries with 50% workers poses a big problem. But yeah, they are continuing their productions. But after all this, the positive side is mechanical engineering are they're back in form. They are already in process in adopting Industry 4.0. What is Industry 4.0? This is the new normal industries. As we all know, due to this COVID-19 crisis, there are many different companies who are eliminating those human labors with machines. This crisis-driven the tech mechanization will bless the industries with realization, flexibility, reliability, and greater accuracy and production. Demand of counter COVID-19 product has opened a new horizon in the mechanical engineering industries, which I am talking about the oxygen concentrator and those mechanical ventilations. This poses a new domain in those mechanical engineering field. So the next topic is about what are the career opportunities in mechanical engineering department. I would like to request my fellow teammate Devrup Mukherjee to continue this topic. Over to you, Devrup.
Thank you so much,
Shomallo, and I would like to warm welcome all of you in the presentation. So, the career opportunity in mechanical engineering. It is a great prospect, I think so. And with that, let's start it. In a survey conducted by the Career Option, it reveals that 60% of mechanical engineer graduates go to private companies like Tata Consultancy Service, Fusion BPO, Tata Motors, Mohan Motors, Telecom, Philips, etc. as sales advisor, assembly line worker, customer care executive, and others. In the core sector, we get only 10% mechanical. The companies which hire them are Tata Motors, Tata Power, Bharatwar, Factory Pump, etc. As a manufacturing line worker, designs or surveillance worker. In software companies, we get only 5% job vacancy for the mechanical. The companies which hire them are Wipro, Google, Microsoft, Player Unknown Battleground, mainly as software designer or web designer. And only 1 to 2% mechanical graduates go to government sectors like PWD, CPWD, UPSC, SPSC, and Indian Army as an high post engineer or an civil servant, and many others. Next slide. So, what are the other sectors which mechanical work for? In the day-to-day life, it is important to know that the mechanical are venturing through other sectors like aerospace. Recently, it revealed that mechanical engineering is present in aerospace engineering as it combined a material of manufacturing and maintenance, which itself is a component of mechanical. In nuclear power plant, we have machineries which can only be operated and maintained by a mechanical engineer. So nuclear power plant also had mechanical engineer. Control and instrumentation. In the development sectors of the various types of instrument, we see the design, development, manufacturing, and maintenance, which is itself a component of the mechanical engineering subject. So there is also a hint present of a mechanical engineer. Next slide. So the next slide will be research and development in mechanical engineering. It imbibes the higher studies also. In short, mechanical can do many more things except like doing MTech or PhD in their own domain. They can do short courses like CAD, pipeline engineering, and many others. MTech they can do in designing, thermal, or the production engineering. And if we go to the research sector, there is robotics, material, nanotechnology, vibration, which is imbibed in the IIT Kharagpur and many other high posted or high institutions. So nowadays in the government sector also there is a important part in the research and development like DRDO, Indian Oil, NPTEL, BHEL, and many other sectors also include mechanical for their daily uses in the development sectors. Next slide. Next slide. So I would like to conclude this with this short note that we are thankful to Techno India Banipur for organizing this wonderful course. As we are diploma engineers, so we know the basic things, and we have get crystal clear evidence in this very short time due to our faculty members. We all would like to thank our faculty members for this. Thank you. Over to the moderators.
Well, that was a very informative presentation by the team of Debru Mukherjee. Thank you for such informations. So before we move on to our next teams, I want to give rules that every speaker has to keep their videos on while presenting. Otherwise, your marks will be deducted as far as the rules. So now I would like to call Sritama Pal for moving on to the next teams.
Yes, Ritik. After the presentation of Team Debru Mukherjee, now let's be ready for the next presentation to come. The team MakeTech now present their presentation. So Team MakeTech, all the best. Now the platform is yours.
Hello, am I audible and visible? Someone please respond.
Yes, you are visible.
Rohan, are you here? Rohan, Mayuk?
Yeah, I'm here.
So I'm about to present my screen. Please do inform me if there are any places. Now can you see my entire screen? Yeah. So now can you see me?
Yeah, Vijay, you are clear and your screen is
Okay. So now we can start. Okay, so let's start with the presentation. A very hearty good afternoon to all my teachers and principals are present here, and all my juniors and my classmates are present here as well. Today we have gathered here to discuss about the importance of mechanical engineering. And personally for me, this topic is very personal because throughout my engineering, the questions that have been addressed here have been asked to me by my friends from the CS department and my ECE department, and the response was always that it is not how it looks. Mechanical engineering has its fair share of opportunities. Well, let's talk about a few opportunities later on. Let me talk about the latest advancement or the latest branch of technology which has come out of mechanical engineering, which is nanotechnology. Let me quickly run you through the content of today's presentation. So it is going to go from nanotechnology. We are going to learn what nanotechnology is and a few advancements of nanotechnology and its applications. And then we'll go to advancements in mechanical engineering, where my friend will explain you the various advancements other than nanotechnology which has happened in mechanical engineering. And finally, my friend Mayuk will explain to you the opportunities as an entrepreneur, like being a mechanical engineer, how much opportunities you get to become an entrepreneur. Okay. So before we start to learn about nanotechnology, we need to understand what is nanotechnology. So here's an image that will help you appreciate what as scientists and engineers we have achieved. So over here, Rohan, could you just confirm that everybody can see, if you can see my mouse cursor?
Yeah, I can see your mouse cursor very clearly.
Okay, thank you. So over here we can see that there is the ant, approximate length 5 millimeters. Smaller than that, we'll find a dust mite, 200 micrometers. Then even smaller, when we go even smaller than that, then we'll find a human hair. The thickness of a human hair will go from anything between 10 to 50 micrometers. Then we have Then we have red blood cells over here, which is even smaller, which goes from 2 to 5 micrometers. Then we can see over here that we have a DNA structure. Now, right between our DNA structure and our blood cells, there's a region. There's a region which is between 10 to the power minus 7 and 10 to the power minus 10. That is where nanotechnology happens. As we can read over here, that 1 nanometer is about the length which our fingernail grows in 1 second. It is unimaginably small, and that is how small we can compress technology. And this has not been pre-existing for entirety. We have developed this in less than 100 years. This is why I want everyone over here in this meeting to appreciate how much as engineers and scientists we have achieved over here, right? Okay, now that we have understood what nanotechnology is any technology which operates or functions in a length below 10 to the power minus 10 to the power minus 9 meters. Now let's look at nanotechnology as a whole. So as I already told you, nanotechnology is any machine or any robot which functions or any process which functions at a very small space, anywhere between 10 to the power minus 9, and it could be even smaller than that. Now its application can be anywhere and everywhere you can look at. Nanotechnology has been explained by many experts in this field as a household name for the future, just how plastic has become now. Because let's face it, nanofabrics, a lot of us have worn nanofabric without even knowing it. We have all had ads of self-cleaning t-shirts or self-drying t-shirts. Now, how is that achieved? Common cotton or the general cotton that is produced cannot do that. That is where nanotechnology comes in. Okay, so it is nanotechnology has branched off from mechanical engineering, but I should not forget to mention that it epitomizes knowledge from biology, be it physics, be it chemistry, and of course mechanical engineering. It is not just a single-handed contribution of mechanical engineering, of course. Now, this technology has been used, changed, interchanged, iterated upon to fit different technological verticals so as to get the most profitability out of this technology. Let's look at some examples of what we have achieved through nanotechnology so far. Now, to start with, to give you a little connection about nanotechnology and how mechanical engineering, what nanotechnology and mechanical engineering together has achieved. So, design and production of nanomaterials always uses mechanical engineering. So, over there you can hold a loop, right? Now, carbon nanomaterials are being used for aerospace engineering. Now, I don't have to tell you that heavy materials don't fly. So, we need lighter materials to make our planes, and this struggle to find ever lighter materials has been there from right when Wright brothers have invented the plane, and ever since that we have been searching for lighter and lighter materials to build our planes with, so that they fly other distances with less fuel. Now, thirdly, I would like to tell you about 3D printing and nanotechnology. And over here, you can read by yourself that a university which goes by the name Rutgers University in USA Research has developed a way of binding nanoparticles using 3D technology. Now, what this is going to do is it is going to bring down the cost and manufacturing of nanotechnology. Nanotechnology such as your touchscreen AMOLED screen on your phone. That is nanotechnology. That is the example of nanotechnology. This is why previously I had already mentioned that a lot of us use nanotechnology even without knowing it. Now, another vertical where nanotechnology has tremendously or will tremendously eventually affect the industry is thermal engineering. Now, if a lot of you being from first year or second year or trying to get into mechanical engineering don't know that heat, which is produced as a byproduct, is not liked or appreciated. So we try to get that heat out as soon as possible. But the current technology which we use is making fins, or in short, or in simplicity, increasing the surface area. This is why on the surface of a motor you see layers of spikes, which are long spikes, right? Those are called fins. They have no other function other than heat ejection, right? But that technology has existed for a long time now, and it is finally being challenged now by nanoparticles. Over here, you can read that using nanoparticles, almost 100% thermal conductivity using liquid coolants can be achieved, and this has attracted a lot of companies to adapt nanotechnology in their production. Now, another thing before I move to the next slide is fuel production. Now, fuel production has always been a problem for our society. USA does not invest heavily in the Midwest just for international relations. Oil is one of the reasons, right? So oil has always been a very controversial fuel all around the world. Okay, just a second, sir. I would like to apologize. My battery ran out. Just give me a few seconds. I'll. Can you hear me?
Yeah, you're audible.
Yes, you are audible.
Yeah, okay. Okay, so I'll just resume from where I was. And sorry guys for the delay. I should have been more careful. I'm sorry about that. So where were we? Let me just switch off my.
Nanotechnology is the fuel.
Yeah. Let me just switch off my ceiling fan so that everyone can hear me loud and clear without any disturbation. So where was I? Yeah, fuel production. So fuel has always been game-changing, resource to have. The world wars that happened were also won due to the oil availability that the Allied power had. If nobody knew about this, then this is just a fact. We learn something new every day. And now nanotechnology is being brought into fuel production, and nanotechnology can be used to gather fuel and extract it out of the ore or the raw material, so that at the end customers get the fuel at a cheaper price, right? Now, if I want to go on and on, then we will probably be sitting here till dawn, because nanotechnology can essentially be applied to anything, be it the energy sector, be it optical engineering, be it the defense sector, and I've already mentioned about nanofabric, and of course, cosmetics also has a good amount of nanotechnology involved. But so what I'm going to do is I'm going to go for the technological vertical that I like the most, so that the words that I speak can come out of passion. Okay. So fuel cells is something. Fuel cells is something where I feel that nanotechnology is going to bring a tremendous impact, and we should all prepare ourselves. Now, we all know what a fuel cell is. We have studied it in our class 11 and 12. If there is someone who does not know what a fuel cell is, well, fuel cell is an electrochemical cell, or a battery in short, that converts mostly hydrogen and oxygen to give out a redox reaction and electricity as a byproduct. Now, this over here is a fuel cell, and over here we can see a membrane. Now, innovation using nanotechnology has happened on two parts. Now, first of all, I would like to go with you on the membrane. Now, what the membrane is made of in general cases in a fuel cell, if I'm speaking to a layman, is made out of platinum. Now, platinum is a very expensive material, and what now industry is trying to do is replace this platinum with nanoparticles of platinum or nano-ops of other materials, so as to eliminate the need or the requirement of platinum altogether. Now, the second thing that I would like to cover is that the catalyst of fuel cells is also trying to be a problem when we are trying to implement them in our modern cars, because the catalyst which is used in fuel cells is also platinum, and is actually a big chunk of the cost which goes into making a fuel cell actually goes into buying and securing the platinum. Now, if nanoparticles of platinum or any other material which shows the same properties such as platinum can be found, then we can imagine a world where fuel will not be required to run our automobiles, and they can entirely run using renewable energy sources. Now, let me show. So this is another vertical where nanotechnology has promised for a greater future. Now, I've talked about how nanotechnology can be implemented on cells of a car or a battery of a car, so as to increase the longevity and the efficiency, so that electric cars go a greater distance and perform better. Now, if a lot of people don't know over here, being in first year or second year, then the biggest problem to switch to electric cars right now is that electric cars don't give a great mileage as well as those running on diesel or petrol does. Now, what scientists at Tesla and I believe other automobile giants will soon add in they are researching for a material which sticks to the exoskeleton of the car or the surface of the car and acts as a battery. Now we can over here, we can see over here, observe that the upper layer is supposed to be carbon fiber, and fiberglass is supposed to be a membrane. As I showed you, fuel cell also needs a membrane to separate the positive from the negative. So carbon fiber can act on the top, and carbon fiber can also act on the bottom, and fiberglass can act as a membrane and act as a battery in total. Now what this will do is it will make the car lighter, help the car achieve greater mileage, and also it will make a world without fuel, without being dependent on fuel such as petrol or diesel, actually possible. Right. So there are other advancements happening in mechanical engineering all around the world all the time. And I would like to bring my friend Rohan Verma in to talk to you about and explain to you about the various advancements in mechanical engineering, other than nanotechnology, that is. Rohan, can we please have you here?
Yeah, please. So, as Vijit has already introduced you to nanotechnology, let me cover biomimicking 4D technology and scramjet very quickly and very efficiently. What is biomimicking? You already know about bio. It's about biodiversity, nature, and animals. So what we are right now, scientists are doing, they are following the nature. They are seeing what the animals are doing, what is going on about in our nature, and then getting inspired to build something out of it. For example, scientist in USA is being inspired by cockroaches to build robots which can travel into different terrains, being mountain, being anywhere. These will help us to ensure our environment and also the search and rescue operations. There are there are sensors being organized by or inspired by butterflies, which will help us to increase the sensing of bombs and all, which will reduce the cost of metal detectors and every aeroports securities and all by a lot. By margin is 100 times lot. Now, what is 4D technology? 4D technology is nothing but an advanced form of 3D technology in which you can just print anything which can change its shape with time. Now, the team which is working on this includes, but not limited to, MIT, one of the premier leading mechanical engineering college, and Harvard's Wyss Institute. With this, you can programmable materials which will change its shape depending on the size and situation and the stimulus that you apply to the team. So, Vijay, can you kindly change the slide so we can cover on to the next topic? Vijay, change the slide. Vijay, next slide. Oh, so last I would covering is scramjet. Scramjet is supersonic combustion ramjet. As you already know, ramjet, what is ramjet, which is being used in rockets, which gives it extra speed to cross our terrestrial terrestrial atmosphere and go on to other planets and research or for development. Right now, our rockets are at a speed of 7,400 kilometers, and with the scramjet, it will reach to a speed of 17,890 kilometers per hour, which will ensure us to go beyond Mars to Jupiter and Neptune and Saturn. Also, right now it takes almost 17-18 hours to travel from India to USA. When once scramjet is out, as applied by NASA, it will take us just 7 hours to travel from India to USA with a speed of over 7,890 kilometers. You can see below is the plane which is NASA working on is X-43A plane. Now, as we have already talked about advancement, now I will give it to Mayuk to contribute about opportunities as an entrepreneur. Please, Mayuk, can you take over and continue?
Thanks, Rohan. Now I am going to carry forward the PPT from here. So let me tell you the audience that who are the entrepreneurs. Actually, they are that person who takes the financial and market risks with the unique ideas, with unique business ideas, and uses the modern technology to achieve any goal, to achieve any dream, for making profit, for serving the mankind, for serving the world as well as our nation. So if we can, if we look into the field of mechanical engineering, we can find many of them, as I would like to tell that a mechanical engineer is responsible for various tasks like analyzing the issues to determine how a device can solve any problem, or we can also recommend the remedies when there is any fault in the equipments. And on the basis of this problem solving skills, on the basis of the creativity, on the basis of the knowledge that we have gained during our BTech, during MTech, or the higher studies in mechanical engineering, we can use that knowledges in many kind of entrepreneurships. Like in this slide, we can see there are 7 topics. Now, I would like to tell about I would like to tell something about the nut and bolt mechanism and this kind of farms. Like the demand of the fastener technology, like nuts and bolts are there, is very high in our modern world. Like a report recently that has been published, they had said that the demand is going to a market value of 7,703 billion by the end of 2023. So there is a huge scope. If you are going to do any entrepreneurship, then this would be a perfect platform for you. Now, I would like to tell something about the supply chain management. Now, it involves a series of activities that make and distribute products between the farm and the customer. Now, in this section, there is a huge scope of growth rate and that can affect in the success of your startup. Now, I would like to tell about something about the consultancy firm, opening a consultancy firm. As a mechanical engineer, you can open up a consultancy firm. Yes, it is true that at first it is hard, but as you are going to do the hard work, as like in the understanding of the budget, by increasing the personal bandwidth with the clients, with the successful entrepreneurs, you can easily do and you can easily deliver best result to your clients. Now, I would like to tell Bijit, please move on to the next slide. Okay, here are the pictures, and I think all of us know these persons, as their groups are directly linked up to our life with our everyday life. Like the man who is here, Mr. John Rockefeller. He's the father of the oil industry business, as we all know that he at first started the invention of refining the petroleum from the crude oil. Now the second one is Mr. Charles Koch. Charles Koch is an American businessman and philanthropist. He is also a mechanical engineer, and I would like to tell you all that is not mentioned here, that the total asset value as per 2020, Koch Industries total turnover and asset value is near about $115 billion, and they works upon refining and distribution of petroleum. Not only these foreigners, our Indians are also here, like Jahangir Ratanji Dadabhai Tata, or in short, he is JRD Tata. We know that Jamshedji Tata was the founder of Tata Group, but in future, JRD Tata, who is also a Bharat Ratna, has bring forward the business of Tata Group, and he has expanded the Tata Group to globally. And we all know that in our everyday life, from teeth to toe, Tata is everywhere. Please, Bijit, next slide. Bijit. Now I'd like to tell about Mr. Henry Ford. Henry Ford is the founder of Ford Motor Company, and he just started the Ford Motor Company business with just $28,000. But recently, in today, the Ford Motors total annual asset is rupees $228 billion. Now the next one is Lakshman Rao Kirloskar. We all know about the Kirloskar group and the Kirloskar pumps. It is an interesting fact that our college TECB also uses the Kirloskar pumps in our mechanical workshop. Now we can easily say that how much visionary he was, that he invented the Kirloskar group, and we are getting the fruit from his company. Now the interesting fact is Mr. Ankit Bhati, who is mentioned here. Ankit Bhati is a mechanical engineer, but
Mayuk, let me interrupt. It's going a lot of in here. Please conclude it here. Kindly conclude it here. This is end.
Okay. So, Mr. Ankit Bhati, there is an interesting fact I would like to tell, and then I will conclude this. He is the founder of Ola Group, and though he had done the mechanical engineering, but he started the app-based cab service, and we can easily say that if you are from a core stream, then it is not that you are binded to that core stream. You can easily switch over to any kind of industry. Bijit, next slide. Bijit. Okay, so that's all from our group, and I would like to thank all of you, and that's all.
Okay, thank you, Team MakeTech. And you gave us so many valuable information about how mechanical engineering is related to nanotechnology. So moving around the next presentation, I would like to say that our time is actually fixed. We already know that. So I hope we already do this keep in mind. Okay, so now our third team, Amigos Mecanzo, will present their presentation. So are you ready, Amigos Mecanzo?
Yes.
Okay.
Good evening to all. Today we will be going to represent on the topic the mechanical way, where we will be discussing about the different aspects of mechanical engineering. So before moving on to our topics, I want to introduce our team. The name of our team is Amigos Mecanzo, whose leader is Ritik De, followed by Sitama Pal, Shamik Sarkar, Abhinav Kumar Das, and Shavik Bhaumik. So in the next slide, we will be moving about the mission. So in this, we will be giving a representation of mechanical engineering on 3 topics. What is mechanical engineering, which will be discussed by me, Ritik De. Second point, the evolution of mechanical engineering until 2000. Before the emergence of software in electronics. This will be discussed by my friend Sitama Pal. The third point, the uses of mechanical engineering in our daily life. This topic will be discussed by my friend Abhinav Kumar Das. So before moving on to our next topics, I want to say thank you to my teammates Shamik Sarkar and Shavik Bhaumik for giving us the information. So let's start. The mechanical engineering has always been a basic part of engineering branch right from the start of scientific revolution. So we know that before the emergence of electronics and software, the knowledge of mechanics had been used to create questions, tools, building blocks, houses.
Ritik,
yes.
Your video is not on.
Oh, sorry.
Yes.
Where do yes, the manufacturing of coins, tools, machines, building blocks were all parts of mechanics. So before the emergence of electronics, these were the basic tools and these were already referred as mechanicals. Long before the development in the fields of technology, the basic things of mechanics were used, which was later referred as mechanical engineering. Later, this department was mechanics were referred as the mechanical engineering, where different things were based and distinguished. Moving on to the next slide. So moving on to the next slide, we will see what is mechanical engineering. Mechanical engineering is an engineering branch that combines engineering laws of nature, which helps us advance our surroundings and environmental issues. This means that mechanical engineering is one of the engineering branches which combines the laws of nature to our surrounding environments to advance our comfort zones or living procedures. So in this case, we will look at the mechanism, forces of winds, thermal powers. These are the part, very little things or the start of the initials, which later converted as the comforts of our zones. It was all started with the invention of steam engines, which got a enormous evolution in the scientific world. The steam engine was powered by the power of water vapor, which later rotates the turbine forces to create energy so that the train can move. This has created the whole world an impact of mechanical engineering through the knowledge of mechanics. The second point is the mechanical engineering is the application of principles, problem-solving techniques, engineering from design to manufacturing to the marketplace of any object. Mechanical engineers are also a part of solving problems because they have come through various engineering and solve a particular problem on a particular basis. So moving on to the points, we will see that first, the problem-solving technique. So before solving a problem or creating a tools or machine, we will come through small tools or regulators like nuts, bolts. These are all basic parts of mechanics which is used to manufacture different objects. So where does it comes in the marketplace? Yes, it comes in the marketplace as it is based on the small scale industries which has created large scale industries. So we all know that without the raw materials, we cannot create the tools we require in the world today. So we can easily say that the small scale industries which create small tools like nuts, bolts, hammers, also being a part of a marketplace so that we can keep up with the economics of the world. Mechanical engineers are different. That's because mechanical engineers create centers on creating technologies to meet human. The world is continuous tools to rotate. So before we used to use cars, cycles for land places. That problem was waterways or airways. Over the human made ships. Later, not a cosmos or the to learn about different planets. Up with the idea of spacecraft, which we can move to the universe or the outer space to gather knowledge and other informative things that we get through different aspects. Moving on to the next slide. We will see that mechanical engineering has also developed in the fields of renewable resources. It means that all the today's world, we will see that we are already dependent on the non-renewable sources like coals, petroleum, foods, and other things because already non-renewable and they take a lot of times like the millions of years to create things. So it is nearly extinct and cannot be recreated. So it is our duty to develop our resources to a non-renewable source of field energy, such as the windmills, thermal power plant, nuclear power plant, and so on. So we can see that the wind energy or solar energy are present in the unlimited ways, or we can go up to a higher place to gather more energy. So we can see also get about the nuclear energy. In the nuclear power plant, we get a free sustainable energy which has a huge impact or a huge amount of source which can clarify or activates more powers. So for an example, we can see the cyclotron in which the nuclear power plant are measured. This is a part of mechanical engineering which uses the concept of nuclear fission in which the collision of one atom strikes with another atom to create a huge amount of energy which is later stored to create energy for different forces. Fifth point, mechanical engineering is an incredibly broad field and provides the engineer a number of different areas. In these areas, we will see that the above 4 points I have already discussed that we have come to a small scale industries, to small tools, to a large scale spaceship and satellites. So mechanical engineering has been a basic and the fundamental part of every engineering branch or every scientific revolution. So we can see that a mechanical engineer who has the basic knowledge of everything can go up to specialization in anything. So we see that even the defense or the defense forces also uses mechanical engineers or for the maintenance of the battleships, or we have a chief engineer to look after the spacecraft and other valuable defense systems which can be improved or advanced in the future. So mechanical engineers are rather more effective in the different fields with the help of electronics and software engineering. Now I am to call upon our next team member, Sritoma Pal, to move on to our next slide.
Thank you, Ritik. So hello everyone. Today I am going to describe about evolution of mechanical engineering. So from decades, different mechanical instruments have been developed. And till year 2000, so many remarkable inventions that today I want to discuss here. See, as per our views, mechanical engineering techniques are introduced. People are reshaping their environment as per their needs and wants since before recorded history. So there have always been people who designed and built tools and other devices to solve their daily needs and improve their lives. So development in industrial revolution is enhancing the dependence and look to machines in order to increasing the work output, accordingly making the production more reliable and efficient. So growing knowledge, experience in the field of mechanical engineering has led so many scientists to invent and introduce so many mechanical machines. So in the next slide, Ritik, please change the slide.
Yes,
so in the next slide, we will see some works. Like Isaac Singer was the person who invented continuous stitch sewing machine. Another example, we can say that Andrew Halliday invents cable car. Next, Christopher Soles was the first practical typewriter. Then Joseph Glidden invents barbed wire, which we generally use to put as a fence. So like this, in the next slide, Ritik, please change the slide.
Yes.
Okay, so in this slide, we will see some more inventions between the year 1900 to 1950 by some remarkable scientists. Like vacuum cleaner was invented in 1901, which is based on Bernoulli's principle, and it is one of the most handiest domestic cleaner, you can say cleaner or domestic appliances used today. So in the year 1904, radar was invented, which is used to detect and track spacecraft, aircraft, and at sea, as well as insects in the atmosphere. So it also measured the speed of the automobiles also. So jet engine was invented in the year 1930, which uses the same principle as a car engine because it burns fuel with air to release some energy that powers a vehicle, a machine, a car, etc. So we can say the steno-type machines were introduced in the year 1911, and so many machines like this, wheelchair, folding wheelchair, helicopters, microwave, oven automations, like this type of machines are introduced in the year between the year 1900 to 1950. Okay, so in the next slide, from the year 1951 to 1990, we can see some more inventions. Like transistor radio was invented in the year 1953, which are still commonly used as a car radios. The pocket size of transistor radios sparked a change in popular music listening habits because it's allowing people to listen music anywhere they want. In the year 1957, satellite was invented, which looking towards Earth provide information about cloud, oceans, sea, land, and it also measures the gases of atmosphere. Car seatbelt was introduced in the year 1959. Biometrics were invented in the year 1968, which is used for identification and access control for who are under surveillance. In the year 1973, car airbags were introduced. So besides this type of machines, MRI scanner, laser printer, disposable lighter, so many things are introduced between the year 1951 to 1990. So due to new and growing inventions in mechanical engineering systems have also reached to their support as a mechanical engineer, the world population to access clean, fresh water, adequate shelter with the help of latent advanced technologies. So now I would want to request to my friend Agni to continue with the presentation. Thank you.
Pitama. So I would like to tell you about the daily uses of mechanical engineering. Mechanical engineering is applied in a very wide range of areas. They all affect our daily life in one way or another, like the electric power, refrigerators and air conditioners, automobiles such as bikes, cars, locomotives, etc., which are used for traveling, printed circuit boards used for electronics, production of steel and other metals, which we use in our daily life, water coolers and air coolers, the water pumps which are used for lifting water, elevator, the instrument used by doctors. Beside that, many of the machines we encounter like dust, many domestic appliances and tools, climate control systems, nanotechnology, many of the machines of the modern warfare such as armored vehicles, ships, aircrafts, artillery and firearms. To put it simply, mechanical engineering is a branch that has to deal with the things that move or rotate. It also deals with energy conversions and forces. So some of the applications of mechanical engineering in our day-to-day life are from waking up in the morning to going to college and resting in the room under AC at the end of the day. We go through different kind of machine or tools which is a part of mechanical engineering. The clock we use, it's made up of gears. The cars we travel is made up of the different tools. The elevator we use is based on the pulley system. Starting from the bike to the AC in the room is based on the mechanical systems which are implemented with technology of electronics and software. Even the refrigerator we use is based on the principle of thermodynamics, which is a part of mechanical engineering. The generator used is made of the AC motor principle, which alters the flow of current and helps in the production of power when there is a power supply fails. These are the few examples we see in our surroundings. We will see different kinds of things that are basically results of mechanical engineering. To keep it exaggerated, the Earth's rotation is the product of mechanical engineering. And yes, we mechanical engineers move the world. So I would like to conclude our presentation. Mechanical engineering is being a part of our life, which stands as basic unit of everything we use. Starting with the invention of steam engine to the most powerful space shuttle, the evolution of mechanical engineering has impacted our life in different fields, whether in the field of research to medical applications. The branch helps us even in the dependence of renewable resources. So, as a part of such a wonderful branch, we will looking forward to be a better and advanced future. As a second year mechanical engineering student, we all put our heart to be a better engineer to accomplish much bigger things we have till date. I would like to thank our respected principal and teachers for giving us such opportunity to represent ourselves. Thank you. Stay home, stay safe.
Thank you, Team Amigos, for giving us such informative presentations. So without wasting any time, I will to call up our next team. And to call up our next team, the Smiling Buddha. Please come forward. The platform is yours.
Avoy, please present your screen.
Yes.
Good afternoon, everyone, and welcome to my presentation. First of all, let me thank you all for coming here today. I hope all of you are doing well during this pandemic situation. My name is Amit Roy. I am a student of Techno Engineering College, Banipur, Department of Mechanical Engineering, third year. We all know that our department arranged a presentation competition named The Mechanical Way. In this program, I am going to represent my team, Smiling Buddha. My teammates are Avoy Pal and Rohit Das. First of all, I would like to give you an overview of mechanical engineering. Mechanical engineering is one of the oldest and broadest engineering fields. It brings together creativity and design with maths and physics together to analyze and test the limits of products, process, and technologies. Mechanical engineering has always been present in the world, but the invention of the steam engine in the later part of the 18th century, providing a key source of power for the Industrial Revolution, gave an enormous impetus to the development of machinery of all types. As a result, a new major classification of engineering dealing with tools and machines developed, receiving formal recognition in 1847 in the founding of the Institution of Mechanical Engineering in Birmingham. Here you can see a model of a beam engine featuring James Watt's parallel linkage for double action. James Watt is known as the father of mechanical engineering. Before my presentation, Team Amigos Mecanzo talks about the evolution of mechanical engineering until 2000. They talk about some novel inventions like IC engine, jet engine, and of course aeroplanes and etc. And lots of other things. Now I am going to discuss how the mechanical engineering branch will evolve in future. Civil, mechanical, and electrical engineering are considered as the mother of engineering. In other terms, these are core branches. Look around in any non-mechanical engineering area. You will find mechanical engineering uses. Take civil industry, which is doing fast with the help of heavy, more precise mechanical equipment. Look at the electrical industry, which is also heavily dependent on the mechanical industry, starting from power generation, plant machinery to distribution network. Look at the chemical industry, which is also dependent on the mechanical industry in terms of chemical factory setup, equipment, etc. Even you take medical industry, in which robotic operations, diagnostic machinery are mechanical equipment. The list is endless. Now coming to the future of mechanical industry. The future lies in the merging of multiple industries to create new and innovative solutions. Mechatronics is one such example in which mechanical engineering works with electronics. Did you see a common thread on all evolving areas? Robotics, space science, green technology, 3D bioprinting, IT, or anything else, all have a work with mechanical support. Therefore, if you are a mechanical engineer, be rest assured it is going to penetrate all industries. There is no end of possibilities of new solutions. Now let's deep dive into these 5 sectors of mechanical engineering. I am going to start with mechatronics. It is the field of study integrating mechanical and electronics principles onto a single device. Mechatronic systems are conglomeration of electronics, mechanical systems, and computer science. Examples include escalators, elevators, refrigerators, photocopier machine, auto sliding door, anti-lock systems, robots, and etc. Robots is inarguably among the most famous and well-researched offspring of mechatronics. Robotics is the field of study integrating computer science, electrical, and mechanical engineering primarily. It is a more specialized field of mechatronics engineering. Bipedal robots, rockets, self-driving cars, Hyperloop, currently being developed, are all examples of mechatronic systems. Improvements and groundbreaking research conducted within computer science will simply boost robotic systems and ultimately mechatronics. According to me, as long as computer science shines, robotics will thrive. As long as robotics will thrive, mechatronics will shine. Now let's focus on aerospace engineering. Aerospace engineering is a branch of engineering that provides skills and knowledge to design, manufacture, and maintain spacecraft, aircraft, missiles, and weapon systems. Every developed nation is characterized by modern and large airports, airlines, rapid and fast transportation of goods and people. Globalization demands good connectivity between countries and cities within the country, which will only possible through the development of aerospace engineering. Good defense of the country needs economic and high technological capability of the nation. Fighter planes, missiles, rockets, ICBM means intercontinental ballistic missile, etc. Lots of aeronautical engineers are needed to manufacture and maintain defense aeronautical logistics. Flying cars are a possibility in the near future. Most people in the world and India may be able to afford flying cars. This will need a lot of aeronautical aerospace engineering to maintain and manufacture flying cars. In conclusion, in the long term, the scope for mechanical engineering in the aerospace industry is excellent. Next, deep dive into space science. I think there is no need to explain what is space science because we all know what it is. Mechanical engineers play a very important role in every mission by any space agency. I will try to highlight some major fields of work for them. That is design of launch vehicle, propulsion system design, thermal system design, trajectory design. Apart from these, there are many other activities where mechanical engineers are involved. we can hope a very bright and exciting time for space engineering is coming. Now, I am giving some examples of what we could get within the next 5 years. First one is GSLV Mk3. It will also be established as a reliable launch vehicle, although I am not sure how much will be used for commercial launch. The last experimental suborbital flight was successful and 2 more are planned. Next one is Chandrayaan 3. The third moon mission of India is planned for 2020, but it was delayed due to COVID-19. It will consist of a lander and a rover. The next one is solar mission. ISRO is landing a solar observatory for research. This mission is called Aditya L1, and the spacecraft will be placed in a critical point called Lagrangian point, which is very difficult. And the last one of this list is Venus and second Mars mission. ISRO is going to Mars for the second time and Venus for the first time within these 5 years. ISRO will try to send a lander and a rover to Mars this time for actual scientific research on Mars. So I think we are going to have colorful days even in the coming 5 years in our space research. The happy future of our space endeavor is waiting for us. Nowadays, the most obvious trend is green technology or environmental engineering. This stems more from government regulations that asking people to use more and more green technology. So things like solar cells, electric cars, hybrid cars will become popular within few decades. Yes, I know this is primarily electrical, but there are also mechanical aspects to it. Renewable energies like wind, solar, wave, hydro, geothermal, etc. are involved with many engineering fields like electrical, civil, chemical, and mechanical engineering. However, energy is a subject of the mechanical engineering branch. In many universities, there is a separate department for renewable energy in the faculty of mechanical engineering. Now, the last one of this category is 3D bioprinting. Three-dimensional bioprinting is the utilization of 3D printing to make artificial organs such as liver and kidneys and other vital human organs to test new drugs more accurately and perhaps eliminate the need for testing in animals. In the future, we may replace the real human organ with artificial organ. The 3D bioprinting process includes 3D scanning, model design, and printing, which is nothing but a part of additive manufacturing. Here we see some evolving areas of mechanical engineering from 2000. And now I can say that a mechanical engineer applies his skill and awareness to making only what you think truly serves a better world. I just give you some examples. Now I request my friend Rohit to discuss the next topic of this presentation.
Good afternoon, everyone. I am Rohit Das. Now I am going to discuss the contribution of mechanical engineering to move the world. According to me, mechanical engineers make things that I used to make every other things. If mechanical engineer was not known to man, we would still be in the Stone Age. When the Stone Age man used a bit of mechanical engineer. Even to produce inconsiderable part of any item, we need to change the form of energy either from heat to work or from work to heat, which cannot be possible without mechanical engineering help. Actually, we cannot make anything without mechanical engineering. Now, I'll give you an example of a day of my life, so you can understand how mechanical engineering is work in our daily life. I wake up in the morning and check the clock on the wall. The hands movement on the clock is a product of mechanical engineering. I realize I'm late and rush to the bathroom. Take the brush and close the door. The door only got closed because of the hinge on it. The hinge is a product of mechanical engineering. I got ready and went to play some tennis. Then I took the racket. The racket is a product of mechanical engineering. Then I got ready and left for college on my cycle. The cycle is a product of mechanical engineering. In the class, the professor wrote on a blackboard. The blackboard is a product of mechanical engineering. After the class ended, I decided to go to the library. I wanted to go to the last floor, which is quite optimal for studying, and I took the elevator for it. And the elevator is a product of mechanical engineering. I studied for a while, and it was terrific as usual. To overcome my sleep, I decided to watch few hours of YouTube video for a while and study later. But like every other student, I ended up watching 6 hours of nothing. But still, my laptop did not get heated because of the fan inside it. The fan is a product of mechanical engineering. I came back home. It was summer and freakishly hot. I immediately turned on the AC to get some sleep. The AC is a product of mechanical engineering. Now, we are very much eager to know the role of mechanical engineering in transportation. There are 4 main modes of transportation. Railways. Almost every aspect of railways relies on the mechanical engineering field, from trucks to signals, trains, ticket barracks, tunnel, even elevator control system are responsibility of engineers. Roadways. Mechanical engineers drive the automotive industry from 80-seater buses to single-seat F1 cars. Aerospace engineers are all about flight, whether that's plane, missiles, rocket. They design more fuel-efficient aircraft that cut emissions, build the fleetest of stylities that power modern GPS technology, and create the next generation of a spacecraft for mission Mars and beyond. Waterways. Engineers in the marine industry usually either opt for the mechanical machine vessels and equipment or design and build them. Designing of transportation facilities include our airport pavement design, toll plaza design, traffic design, signal design, lots of other designs for transportation that cannot be possible without mechanical engineering help. To keep it exaggerated, the Earth's rotation is a product of mechanical engineering. And yes, mechanical engineers move the world. Now I request my friend over to discuss the remaining topic of this presentation.
Good afternoon, everyone. I'm Abhay Pal. Now I'm going to present the remaining part of our presentation. In this part of my presentation, first of all, I would like to talk about how mechanical engineering related to medical science. Have you heard about complex brain surgeries performed by robots in 20 minutes, which once demanded 2 hours of dedicated efforts by surgeons? There's a brief glimpse of mechanical engineering making inroads to surgical bed. But I will give another insight to help you grasp how mechanical engineering can diverge application in medical fields. Don't be surprised when I say mechanical engineers are fighting cancer. Chemotherapy is an extent treatment of cancer. In layman terms, this procedure can be explained by an analogy to treat a house infested with rodents like mouse. In order to kill the mice, should you use a rat kill or should you burn the entire house? I hope you would go with the first choice. But the chemotherapy is a medical in which your entire body is exposed to radiations. Drawing back an analogy from the rodent killing story, chemotherapy is like burning the entire house just to kill rats. So an ideal medical solution would be treating just the infected organ with radiations. Well, can be achieved by targeted drug delivery and the recent developments in microfluids, which is a core area of core area of research in mechanical engineering. That can make this feasible. Now I have outlined a few areas in which both mechanical and biomedical works in. The first one is artificial organs, and second is pharmaceutical industries. As my friend Amit said earlier during discussing about the 3D printing, that we can see direct use of mechanical engineers in artificial organs of human, like artificial heart, cochlear implant, pacemaker, bionic eye, heart-lung machine, and lots of clinical devices like oxygenator, ventilator, and etc. And for the pharmaceutical industry, I want to say that where there is missing, there must be a mechanical engineer. Pharma has a wide scope for mechanical engineers, though they need VForm for QA, QC, and production department. But behind the curtain, there is always mechanical engineer for HVAC. That means the heat, ventilation, and air conditioning, which most important utility of pharmaceutical industry. Handling of all this utility is the responsibility of mechanical engineer only. Now, I want to conclude this presentation after dedicating some sentences to mechanical engineering as a mechanical student. And the sentences are, we rule the sea, we make machines think. We trade beyond the world, when mechanical rest, the world rust. Where mechanical accuracy is our identity, leading is our motto. We are proud to be a mechanical student. Nothing is possible in world without mechanical. At the end, I would say mechanical industry is bound to grow to a limit that is not yet defined. The only limit exists is in your mind. So keep your mind and interest open and keep exploring new solutions which you may create for mechanical itself or other industries. That's cover just about everything what my team wanted to say. Now I would like to thank all of you for your time and attention. Thank you all.
Ritik, you are not
You are
audible.
not audible. Hello.
Yes, yes. Now you are audible.
Oh, did I just see unaudible from the start?
Yes, yes.
Hello.
At the start. From start. Please, Ritik. Start.
That was a wonderful presentation given by the team Smiling Buddha. That was a truly very informative and general presentation given by this team. And we'll, especially the last part of the conclusion, such a inspiring words. We'll surely look forward to be such advanced mechanical engineers in the future. So now I want to call upon our last team, the team Royal Mechanicals. So please come forward. The platform is yours.
Hello.
Yes.
Hello.
Yes, yes.
Good evening to our respected principal, sir, teachers, and my dear students. Thank you for giving us the opportunity to present over here. Myself, Uddhav Ranjan Das, and our group name is Royal Mechanical. Today, we are gathered here in an interdepartmental competition known as the Mechanical Way. So, let's start the presentation. Our first point is mechanical engineering is a part of aerospace. Aerospace engineering is the branch of engineering concerned with the design, development, production, and testing of aircraft, spacecraft, and related equipment and systems. The field has traditionally focused on programs related to atmospheric and space flight, with two main and overlapping disciplines, astronautical engineering and aeronautical engineering. Aeronautical engineering is concerned with design, creation, and maintaining of travel machines, including spacecraft, satellite, helicopter, missiles, aeroplanes, and within the Earth's atmosphere. Astronautical engineering is a particular discipline of engineering that is concerned with the development aircraft, spacecraft that run outside the Earth's atmosphere. Both mechanical and aerospace engineers share their interest in the manufacture, design, testing of device, machines. Their job is to create equipment that runs safely, effectively, and efficiently. They also test and investigate the equipment to make sure that it meets the necessary criteria and measures. There is an overlap in the engineering principles in the both disciplines. However, aerospace engineers challenge flight mechanics and aerodynamics in a way that mechanical engineers usually do not. If one aspires to become a mechanical engineer within the aerospace field, then they will have to become used to thinking like this. Aerospace engineers usually go on to work with the government or military opposed to a regular mechanical engineer, and they may take part with the designing and creating of satellites and weapons. It is essential for a mechanical engineer in the aerospace field to possess strong mechanical and mathematical skills. They will also need computer skills to operate design, software, and run simulations. It's common for those engineers to perform most of their duties in an office. They will also work full-time and project leaders may need to work overtime hours. As mentioned above, a mechanical engineer in the aerospace field will be involved in the design, manufacture and testing of aircraft and the products that the aerospace industry uses. They will design spacecraft structures. These engineers are involved in things like making sure that a satellite is able to withstand the force of a rocket launch and its solar cell will work properly in orbit, and that its rocket engine is efficient with fuel used to reach orbit successfully. They could specialize in projects like mission systems, airframe structural analysis, and design or flight test. Aerospace engineering is important because it allows for the creation of new ideas that impact flight on Earth and in space. Because the aerospace engineering field is so diverse, some aerospace engineers focuses on aircraft on Earth, while others aerospace engineers study aircraft beyond Earth. Aerospace engineers are constantly developing advanced technologies to improve flight and air travel. Our next slide will be discussed by our other group member, Orgo Halda.
Hello? Hello? Hello?
Yes,
Am I audible? Hello?
Yes, yes, you are audible. Yes.
Myself, Orgo Haldar. Good afternoon, everyone. My topic is any change in scenario of mechanical engineering before and after COVID-19. Pandemics like COVID-19 have created a spreading and ever higher threat to human health. High mortality and morbidity pose complex issues to industrial networks and manufacturing, including supply disruptions and demand-side shocks. Supply disruptions are attributed to production disruptions of direct suppliers and global transportations due to health risks and quarantine policies. Increasing panic among consumers and firms has distorted demand patterns and created market anomalies that has affected the ability to ramp up production in some industries. That means in the medical equipment industry and reduced operations in others. That means the aircraft industry. These emerging challenges stemming from COVID-19 required industrial networks to be robust to production disruptions and market environment changes, and the manufacturing system to be agile so that production capacity can be leveraged to be to control risk to support the needs to prevention. Intelligent manufacturing is a promising solution to improve production efficiency in light of the demands of this highly dynamic epidemic situation. IM, that means intelligent manufacturing, is built on enabling complex and real-time decision making within automated manufacturing assets, utilizing data from networked machines and sensors. The technology and engineering sectors have been hit extremely hard with the virus setting off inflationary trends in virtually every sector. Although some sectors could be the worst affected, for some it could be an exceptional growth opportunity. This changed scenario would also decide the choice of careers for engineers and technocrats in the days to come. Automation is going to be the key as it is only cost effective, but also does not get negatively affected by working from home. Be it the education sector, the healthcare industry, the manufacturing sector, or the construction industry, automation with focus on artificial intelligence, data sciences, machine learning, and Internet of Things are going to be the key drivers. Capacity reduction in large companies. A total of 790 companies from the mechanical engineering sector participated in the third VDMA flash survey on corona effects. The proportion of companies making capacity adjustments has rises from 75 to 83% in the last 3 weeks. More and more companies are sending their employees on short-time work and are arranging for production stops and staff reductions, even of parts of core workforce. Large companies with annual sales in excess of 1 billion euros are using these instruments for capacity adjustment more frequently than medium-sized companies, explains the VDMA chief economist. If the measures to the contain the corona pandemic are eased in the foreseeable future, one-third of the companies expect to need 1 to 3 months, and another third expects 3 to 6 months, respectively, to return to normal capacity utilization. More than 20% of the companies surveyed even expect 6 to 12 months for this step. Next point will be discussed by our another team member, Soumik Kormokar. Thank you.
Audible? Hello? Hello?
Yes, you are audible.
Okay. Okay. Our next point is career satisfaction of mechanical engineer. Based on 4,899 received the job of mechanical engineer has received a job satisfaction and rating of 3.73 out of 5. Average mechanical engineer are having satisfied with their job. Mechanical engineer are use maths and physics practice to design and product the world mechanical devices. Gadgets tends to be in high demand all around the world. These are some keys of factor on which satisfaction of mechanical engineer student may be defined as the some points like global opportunities in mechanical engineer are in demand around the world. Every country needs this professional to work on their societies, many products and services. Another important point is high salaries opportunities. Mechanical engineers tends to earn healthy salaries due to demand in all around the world, and every sector qualified professionals have great employment and careers. The next point is forefront of future technologies. If we are exist by technologies advances, mechanical engineer could be the perfect career for us. Mechanical engineers lead on and develop new technologies, design products for a range of industries such as robotics, transport, construction, and healthcare. The next important point is multiple sector. After having a mechanical engineer, we can do for a mechanical for a job in a multiple sector, leading invention in the different varieties of industries and machines. Thank you, all sir, respectable sirs and their students. Thank you.
Okay, thank you, sir. A very innovative presentation by your team. Now we have come to the very end of this program. So all the presentations went very well. Now I am requesting my co-host Ritik to continue.
Thank you. That was a great presentation given by all the teams on the today's final competition of the web mechanical. So now I have to call upon Paula sir to give the vote of thanks to this very presentation competition, the mechanical way. Sir, please give your wonderful words.
Hello.
Yes, sir.
Am I audible?
Yes, sir, you are audible.
A very good evening to respected principal sir, my dear colleagues and beloved students. I am honored to be a part of this wonderful event and also for getting an opportunity to deliver the vote of thanks at the grand finale of the competition on decade of mechanical engineering named the Mechanical Way. Now, I would like to thank to all the participants for their active participation in this wonderful event. The participants were very enthusiastic and presented all the given points in well manner and details. The whole competition was a huge information on mechanical engineering. So I am sure that the participants and audience must have benefited by attending this competition. Now, I sincerely thank our dynamic and respected principal sir for his continuous support on us, and my dear colleagues for organizing this beautiful program and also for gracing the program with their presence. Benjamin Franklin said, "Tell me and I forget, teach me and I remember, involve me and I learn." And Socrates said, "I cannot teach anybody anything I can only make them think. So when you want to learn more, you have to be involved with more projects. And if you want to apply new technologies, different thinking will come out. Then engineering starts. The mechanical engineering has the key role at the center in any research and development as well as in production. Any product that exists in reality is made by a mechanical engineer. So I am proud as a mechanical engineer. At last, I would like to share my special thanks to SB sir, TIC sir for overall monitoring this program, and Mr. Monish Shom, Sritama and Ritik for their hard work and support in this event from the very inception. Once again, I thank everyone whose contribution and presence has made this event as successful. Thank you. Over to you.
Thank you so much, sir. We are very reluctant to be a part of this competition and as well as hosting this competition too. And I think every one of us enjoyed this program. Thanks to Mechanical Department of Techno Engineering College, Banipur, to introduce this kind of competition, which is knowledgeable for students of Techno Engineering College, Banipur, as well as other students also. And I hope we will get some more opportunities like this to show our talents in future. And some amusement work and knowledge sharing activities helps us to boost our likings towards mechanical engineering. So thank you. Over to Ritik.
Thank you, sir, for your warm words. And so, yes, thank you everyone, our respected principals, sir, teachers, faculty members, seniors, and all dear participants. So give us such informative presentations so we can learn so many things. And not only us, the outside of the departments or everyone around the world so could learn that mechanical engineering is one of the best branch or one of the beautiful branch one can ever pursue in their career. So I would like to conclude that the presentation given by our seniors and your friends were very informative and gave us so many things about mechanical engineering. So one said that a person who has the basic knowledge about different aspects has the ability to specialize in anything he wants. So as mechanical engineer has one of the capabilities who has basic and fundamental knowledge about every aspect. So we can see that one can specialize different aspects or different branch or different subjects. So we thank you for giving us such valuable knowledge and this wonderful engineering branch. Now I would like to thank our respected principal teachers for giving such wonderful opportunities to not only show our talents but to show outside world the mechanical engineers also in the best branch. This is the end of our today's program, the final of the presentation competition, the mechanical way. So we will be looking forward to such wonderful programs in our near future. Till then, everyone stay home, stay safe. See you soon. Goodbye.